Let's see, the date is October 10th, 2018. This is this regularly scheduled 6 o'clock meeting of ITSE 2347 Advanced Database Programming. Got a lot to cover today, so I'm going to pretty much get right to it. One of the things that I found out I was hoping to do was to use access forms, as I knew a little bit more about them, only a little bit more about them. But now I find that we are not going to access forms, excuse me, are not going to be compatible with SQL Server user-defined procedures. Access forms would be compatible with SQL Server tables. So if we had a access database and I wanted to migrate my data over to SQL Server and keep the same names of everything, then my tables would continue to work, where I would just see the SQL Server tables appearing to me as if they were access tables. However, if I build it in SQL Server and I build all the procedures and everything, then I will not have access to these in Access. So while I can migrate up, I can't migrate down, is the trick to it. So we're going to have to do something else, and that means that we are going to have to use ASP.NET programming in Visual Studio. And I am somewhat intimidated by this idea because I don't know ASP.NET programming, but I'm going to learn it. They're going to call me the ASP kid in a couple of weeks because I'm going to spend a lot of time on it. Okay, the first thing that we need to do is we need to download that part of Visual Studio. Now, we can get it for free, and let's get it on these computers at least. If you wish to put it on yours, you may. So I'm going to go to let's see, I'm going to turn off these. Okay, I go to a new tab, and what I'm going to search for, I'm going to Google download Visual Studio Community. Community is the word you're looking for in there. There are several versions of it. Community is the free one that you can download, and so we want Community 2017. And there's Visual Studio 2017. That wasn't the one I was expecting. Just try the first one. Here's the first one. There's Community, Professional, and Enterprise. Notice that the Community says free download, Professional and Enterprise say free trial. So we get the Community. We're going to get it for free. And no, I don't want to take a survey. I believe that the download has already happened. I'm going to go look in my downloads, and it's just a little bit over a megabyte. It's 1,200 kilobytes, so it wasn't much. But this is just the hook that uploads him. So this ended up in my downloads. So if I execute this, yes. Are you guys with me? I'm going to say continue. Just a moment, fetching my files. Almost ready. It'll say in a minute. We're almost there, which is a little bit like saying, you know, we're driving to Anchorage, Alaska, and we're almost out of the building. Almost done. We got a long way to go yet. but we don't have to install the whole thing. If you're installing the whole thing, you got a long way to go. Almost there. Okay. Couple things out. The thing that I'm interested in installing is the ASP.NET and web development. The rest of them I don't care about. If I install everything, I'll be here the rest of the night installing it. Okay. So we're only going to install one little piece of it, and that is the ASP, and that is 7.68 gigabytes. So that's not exactly small. Gives us these things. Anyway, I want the ASP.NET web development is the things that I'm trying to install. There are other things over here that I can get. Desktop development and C++, Python. We might end up, I don't know whether we will use data storage or not. Right now, I'm going to just, I'm going to assume we're not. We can always come back and install it. And so I'm just going to click install. And I'm going to let it go because I'm not going to sit here and watch it install. It'll take it about 20 minutes or so. So I'm just going to come back to that in a little while. And you guys that are watching it can let me know when it's done. Okay. What I want to talk about today briefly is transaction isolation levels. And everybody, as soon as you start talking about this, everybody's eyes roll back in their head. So go with me, if you will, today. I don't know that we're going to use much of this on in our code, but it is an important piece. From time to time, you do things that it is important that they either, once they begin, they have to either all happen or none of them happen. Now, the best example of this is moving money from your savings account to your checking account or vice versa. And think of what you have to do. You have to go to your checking account. You have to withdraw money from your checking account. So you read your checking account, take the money out, write the new, whether you take it out front, you read it, write the new value, and then it probably gives you the money. Then you read your destination account, increment that, and then add the money to it. Okay, that all has to work from start to finish. If somebody comes along and unplugs the computer, they have a power failure right in the middle of it, and there are lots of transactions like that. Anything that's got money, it all has to work or it all has to fail. Okay. We accomplish this with transactions. When we set a transaction, and let me show you one here. So this is this web page is good. It's better than what they talk about in the book. Here is a transaction being set. It's simply line 13, begin transaction. And you can give it a name. There, you can have interleaved transactions, but I don't recommend it. It's usually a transaction is just you begin and then you end it. So you think of a transaction like an airplane flight. It's okay, well, it's not great if your airplane doesn't ever take off. But if it takes off, you want it to get to its destination airport and land. That's that halfway there thing that isn't good. So it'd be nice, if we could just back up the airplane and go back to where we came from. That's okay. Or we get all the way there. But we can't have a halfway. Okay. So when I say begin transaction and commit, sometimes you will see it written as commit work, but commit also is good enough. Everything in between there, between the begin transaction and the end transaction, either goes or fails together. Now, what it does, it looks at all the data you're going to need to do that. So if you're moving money from your banking account to your savings account, it has to be able to get a lock on your bank account, your checking account, and a lock on your savings account before it's going to start. If it can't get both of them, it doesn't do anything. Then once it does, it goes through it, makes sure it's happened, makes sure everything is correct. Then at the commit, puts a stamp on it. Okay, that's happened. Okay. First time we've seen transactions like that. Now, transactions have 5 different levels of what we call isolation levels, and this is consistent across databases. Let's see. Begin transaction and commit. Some of them, they let you give them names, so I can say begin transaction tran1, commit tran1. In theory, I think I can go begin transaction tran1, begin transaction tran2, commit tran1, commit tran2. I don't know whether they'll let you interleave them like that. I've never found a reason to. You also have something in the middle of it. You can create what they call a save point. If you have a very long-running transaction, we don't like those, but if you have a very long-running transaction, you can have a save point in the middle, whereas if something goes wrong, you can roll back to that save point. The command to abort the transaction is called rollback. So if you issue a rollback, so commit, and the opposite of the commit is the undo, the rollback. Okay, so when you say rollback, that takes it back to where the transaction started, and nothing has happened. Okay, and so inside of this, you can issue either once you begin a transaction, you can issue either a commit or a rollback, depending on what happens. Question. Rollback is both of them. Whatever happened, and since from begin transaction, everything that happened, it can be one statement or a million statements. When you say roll back, they all roll back. Therefore, what it does, it gives us a way to say undo to some extent. There is a limit to how much you can roll back. Well, if you open a transaction and it gets too long, you will fill up what they call the rollback segment, and you won't be able to do any more work until you either commit or roll back. Some people use it as an undo. I said it doesn't have an undo. That's not exactly true. If you say begin a transaction, then I can undo everything back to the start of the transaction. It's a bit brutal and very consumptive, because as you do things in the transaction, you are locking records, and they're going to stay locked until you issue a commit. It is not considered a good thing to do to lock records and then not commit, wait around and not commit, leave those records locked. It's considered to be a very not nice thing to do in database. You know, you're not being a good neighbor to the rest of the people on there if you open a cursor. When you open a cursor, by the way, you lock all of the records. Okay, there are 5 levels of isolation, and I'm going to put them up here, and then I'm going to give you a web page that I'm going to kind of read you the web page, because I think it says it better than I think I can. Starting from the least restrictive to the most restrictive, read uncommitted means that if you execute any transaction in there under a read uncommitted, it's almost like no locks at all. It will allow me, if I have a read uncommitted level of serialization, I'm gonna go over to the web page and read it. Read committed is the default. That's usually good enough for most things, all the way up to what we call serializable. Heard a couple of people say that in here from time to time. It is serializable means that it is virtually completely isolated from anything else that could happen in the machine. Nothing else can impact that transaction. Let me go over here and read to you what this is. So if you have a read uncommitted, transactions running at this level, do not issue locks. Right? They read the data. Anybody else can read it. Anybody else can be writing it. They just take what they get. Okay? You don't know that before you finish reading, somebody's going to come in there and change it. It could happen. Right? So in the early days of database, there was an airline reservation. It was one of the first distributed database applications, and it was airline reservation system called the Sabre system, I believe. And all of the travel agents all over the world were using this same system. Well, they couldn't update it fast enough to lock the rows. So when they sell a seat, when a travel agent in Frisco sells a seat, another travel agent in Phoenix might be selling that same seat. And they might sell it to two different people at the same time, and both people get billed for that seat. It was very real. It didn't happen very often because the time window was, measured in 0.2 of a second or something, that they both had to hit the seat, but it did happen. Okay, what do? Somebody's going to be upset. Somebody's going to be upset, but if you got a free $200 ticket, would you be less upset? It's cheaper than fixing it. And it stayed that way for a long time. Now we've gotten fast enough that we can execute locking. So once they log in and once they click on a seat, that seat will stay locked for them for about 10 seconds. You can't sit there and look at it all day. That lock will go away on it. But when a travel agent locks it, it stays locked. Now that was an example of an uncommitted read, because it meant that I would be reading something, somebody else would be writing it at the same time, but the fact that they had written it hadn't committed yet. Okay, so I can still read it, and that's considered the cheesiest. Committed read, the read committed, is like. Allows two people to read the same data at the same time. So if you're looking at a record, I can look at the same record at the same time and no problem. If it won't let you update the record, and if you got in there and are updating it, it won't let me read it until you finish updating it. So I can only read committed work. Tells you quite a lot more than you probably want to know. A repeatable read specifies that statements cannot read data that has, I hate it when they say has, it's have been modified but not yet committed by other transactions. So I've changed the data, but it hasn't had a commit yet, okay? And that no other transaction can modify data that has been read. Okay. So this is the higher level of it. This is what you need when you're working in a bank or airline reservations. So if I read a record, it'll let you read it. Two people can read the same record. So I take what we call a read lock. or a lock share, a shared lock, meaning that I've got that record locked, but Donna can also come along and lock the same record to read. If she tries to lock it to write it, it won't let her get the lock because I'm reading it. Now she'll go in line to get the lock. As soon as we're done reading it, as soon as our transaction is over, she'll get the lock exclusive. And now she can change it. But we don't have any bets after the transaction. Inside that transaction, I know that if I read a record, until I'm done with whatever I'm doing with that record and commit my transaction, nobody else can touch that record to write it. And finally, the highest level we come to is the serializable. And we don't really like doing this unless we really need complete isolation. It will block anyone from, it's almost a full table lock, but not quite. It's very resource intensive. It's the same thing as the repeatable read, which says that I'll let two people read, but this one, if you are reading data, you say, okay, select from where, and the where clause, nobody else can write that table such that it would change your data set, right? So it takes a big lock on those data, meaning you say, select where date of birth is less than, let's see, what would be 21 years, 98, 97, 96. This day in 96, be 21 years old. It won't let anybody insert a record or delete a record that would change your data set. So that's about the highest level. And anyway, it looks like this. You can only set one of them. No. Oh, go away. I want Notepad. Okay. There's the command, set transaction isolation level. You usually see it written out in one line. Set transaction isolation level, read committed, semicolon. If you don't say anything, that's probably what it is, but if I had to have that, I'd make sure I set it. It will stay set until something else comes along and changes it. So it doesn't, there's no, when you say begin transaction, if you say begin transaction commit, begin transaction commit, they will all happen, that isolation level will stay set until you change it. Okay. So this is how we allow people to use we allow interleaving of our work. Two people can read the same record at the same time. How is this different from Microsoft Access? In Microsoft Access, you can definitely have more than one user on the database. When I say Microsoft Access is single user, they say, oh, no, it's not so. Yes, it is so. At the table level, only one user can be changing a table, or reading a table, writing a table at one time. So if you want to read a table and somebody else is reading that table, you have to wait until their operation finishes reading. Microsoft Access doesn't have transactions per se at the database level. Questions on that? I'm going to see how my install is doing. 96%, good grief. I'm going to be done with that, and then we can, are you guys installing okay? About you pretty much done? Okay, we'll just let that install, and then we'll test it and see if we can develop a quickie little web application. Okay. I'll give you this URL, and I'll pass out that URL attached to an announcement. Okay, I'm going to do something else now. And now for something completely different. Isolation typically applies in a procedure. You typically do not do isolation in just random, you're typing in SQL. It just takes you too long to type it. I suppose you could do it in a batch file and run it, but the main thing is that once you open a transaction, you want to get out of it as soon as you can. It's probably going to time you out in 10 seconds or so, but that's an awful long time to have a transaction open and running. You want to get done with it quickly. This is why we do not like cursors, because cursors begin a transaction, and it has to get all the way through it. So it's going to lock all those records for read access to the records, or if you're writing them, it's going to take write access on all those records and lock up the whole database, the whole table. So you're usually in a procedure. A procedure in SQL Server is pretty much just like a procedure in any other programming language. You have a name, you have parameters to the procedure. It does some stuff, and it exits. It's a subroutine. So when you call it, control transfers over there, execute, 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 comes to an end. It's done something for you. In our case, it is it's checking and inserting data into a table. The nice thing about a procedure is I can give you access to the procedure without giving you access to the table. That's the whole idea. So we build these procedures and we try to make it as easy as we can, try to keep them as simple as we can keep them to give to the web developer. Then the web developer builds his or her web page around our procedures. And so the web comes along and just executes the procedures. The web application should never see our tables. Web applications never touch our tables. Functions. Functions behave the same way as functions do anyplace else. What does a function do? Function takes some 1 or 0 or more arguments. It does some code in there, and it returns a value to you. And we call these guys scalar valued function. What does a scalar mean? A scalar means that it's okay to sit either place that you want to. So a scalar is a value that can be compared. So it would be like integers are scalar. Any two integers, one's greater than the other one, less than the other one, equal to the other one. Same thing is true with character data or real floating point numbers, anything like that. They're all scalar. Some things are not scalar. For example, a function could return an array. Okay, that would not be scalar, but we can do that anyway. Okay, in database, we have something else that functions can do. Let me bring it up. Well, let's see, where was I? Yeah, did I put that on the desktop? There it is. Okay, here's the first example. And again, I'll give you copies of these. As usual, we have a go before any create, a go after a create. Create or alter function, And in Oracle, we'd say create or replace. It's the same thing. We have the name of the function, and in parentheses, we have 0 or more. Computer scientists called them parameters. A mathematician would call them arguments, whatever. And then the return type. Look at the return type. It's a table valued function. Okay. What this does, it gives me a way of parameterizing the SQL select from where statement. And lets me do a select from where and give it parameters. In this case, I have a date created, and I say select from RPS players where the date it was created is less than or equal to the date I pass it as a parameter. I could have said, I want to see everybody whose name begins with an M, if I'd pass that as a parameter. I could give you anything that's in there, I can parameterize. Now, SQL itself does not take parameters. I can't, even though Access, they claim it can, it's really not. It's they put it in the query, and so you just kind of type it in there and the where clause. You can put it in, you can say where, but I don't have a way of passing variables to it, right? Such that you can't monkey with it. So basically, I'm hiding all of this SQL statement, and the SQL statement is appearing to you to be the results of a function. So this one, when I create this function, guess it would help if I should have a semicolon there. So if I use that and I pass it get date, so I want all of them that were less than or equal to right now. I guess that would be almost everything. I could say get date -5. Oh, I'm just going to show that it works. I think this should just give me everybody. And a bunch of people in there. Okay. And they all, let's see, some of them, okay, how about what if we did 2018? Okay, I'm gonna make it 09. Then that should, I shouldn't see any 10s. Well, I want to see what all I've got in there. I've got 2018 9/26. I'm going to say 2018 10/2. I'm trying to, so that should rule out some of them. There. So I see 9/26s, but I don't see the 10/3s because I'm only seeing things less than 10/2. Okay. So it lets me parameterize it. Now this is very handy when you're writing web applications, because it allows you to make a table available to your, it's a little bit like a view. But in the view I can block what you can see. This way I can block it dynamically. And let me show you how how I've done it. Have used this in programming. My create table. Notice that I have made a change here. In the players, I have a password. Okay, so I give the player, well, the player chooses his or her password. And of course, I would probably say it's not null, and I would probably say it has to be a certain length. And then I have other ways. I'd go into a big, long-winded thing about making sure it's a good password. It'd probably take me a half a page of code to check the password carefully. I'm just going to let them do whatever they want to do with it. And I didn't put any restrictions on it yet. I mean, I probably would, but right now I'm just trying to say that's a password. What? Doesn't have to be unique. I really don't want to say a password's unique, because that would, by that, if a password fails to be inserted on non-unique, I would know that that was a password for somebody. So I don't want to say anything about a password except does it have enough characters in it. Yeah. So I could check that the length was, oh golly, I guess if I wasn't checking to make sure that I had a good password, I'd make it long. It allows spaces in it. Yeah, I could say check that the length is greater than or equal to 10. And then you could even put a phrase in there. But, okay, I've added a password. Now, the other thing, and so let me execute this. And the procedures was the next one. I had to alter procedures. I had to pass the password as version. Now, I didn't validate it. So it's never getting validated in this. I just added it here. And then down at the bottom, when I put it in, I don't know why it's saying it's an invalid column name. It's perfectly valid. Execute, and okay. I don't know what happened. Maybe I had it. Everything's declared. When this happens and you get a bunch of red squiggly lines and nothing is wrong and you execute it and fine, but it's just having that fit, if you'll right click him and come down here and IntelliSense, it's not very IntelliSense enabled. If you click that, it just turns them off. Okay. So you don't have to look at them. Main thing I did, I just added the password. And let's see, I'll open. Here I'm putting in some players. I'm executing the procedures, and I'm putting in some players. So I'm initializing the players, deleting them all, and I'm putting in 3 players.
So is the password not required?
Password is fee, fi, and fo.
Oh, okay.
There's the password. Now, what's wrong with that password besides being too short? It's got some problems. What? Kind of common, but let's don't worry about that. I could make it long. What if it had 15 characters in it? Would it be any more secure? Answer is no. It's stored in plain text. But that's not so much the problem, because I can keep you out of the table. I'll have lots of confidential stuff in the table. The question is, it's going to be passed to the procedure by the web server. The procedure call, it will have to go across the web from the web server to the database server in the procedure call. It'll go across the web in plain text, and that's very bad kimchi. Why? Because it's vulnerable to getting picked off right there. I can keep you out of the database, but if you can get in between us on the link, you can pick that password off. Well, what can I do? Okay, I could encrypt it using what we call an MD5. What's an MD5? You're saying, yeah. It's like a 16-byte checksum. 16 bytes. And so you get and let's see, what is that? That's 128 bits, 128-bit number. And if one little character is off in it, it doesn't look anything like it. If you look at the algorithm for how it works, that MD5, it shifts it and XORs it and shifts it back and rotates it all over the place. And supposedly, you can't generate a code that gives you that checksum. So it's supposed to be a one-way algorithm. I understand it has been run backwards, but it takes an incredible computing power to do it. So if that checksum matches, you know the password. So ideally, you would store the checksum, and then I would just send you the checksum across, and now they know that. Well, what's to stop you from replaying it? Okay, and you enter what we call challenge handshake authentication protocol. I'm getting a little off topic here, but what happens is I just have a counter. I run a sequence in the database, and when you say you want to talk to me, I send you a number. It's fine with me if it's 1, 2, 3, 4. You can guess the number. I don't care. What you do when I send you the number, that's the challenge. So you get a number. Probably it'd just be random. You get this number. You take the number and you put it with and then you take hash your password. Let's hit the other way. Pass your ass word. Hash your password, and then you put the number on it, and then you hash it again. I have the hash of your password. You have your real password. You hash it, I have the hash. You put the number with it, I put the number with it, we both hash it. Each time we talk, I send you a different password. Every time. And that number can just increment by 1 each time. It doesn't hurt anything, because you don't know. It's that hash isn't going to look anything like it did the last time. So it changes each time. And that's what we would implement. Okay, back to this. I don't want to. Okay. Did you notice that this does not have a begin end on it? If I try to put begin, I start getting red lines. Oh no. So if I put a begin end, I should have a red line there. That's okay. Here? Doesn't hurt. That doesn't hurt anything. This one, near begin. Incorrect syntax near begin. Select statements included with a function cannot return data to a client. I don't know what that means, but I can't have a begin end is what that means. Once I get rid of those, it's happy.
Is it because return can only return one thing?
Well, it is one thing. It's the table that was derived from that. You don't have this restriction in Oracle, by the way. It's the table that was derived from that select statement. So it's one thing. It's just a complicated thing. There's nothing wrong with a function that returns a vector. Even, a 200 number vector. I mean, that's fine. A matrix.
It almost seems that we're going to try at the beginning and you would put it after the return and before the select.
Well,
Because
no.
that's a contained statement.
It is. The bottom line is that this is what we call an inline function, and it only does this. It only runs that guy and returns. Okay, I want to do more than one thing. Now, if I wanted to check the password, I could do it inside of that one select statement. So where the name matches the PID, where the PIDs match, the one that came in to me, and where the passwords match. So I could do it here, but I'm going to go do it another way. I'm going to do it with a begin end. And sometimes you're just stuck in this way and you have to do it. So this one is test table 1. And notice I'm taking in the PID. So this is Basher, Slasher, Donner, Blitzen, and then their password. So they provide me with their user ID and their password. And I'm going to give them the back PID, PDate, PName. Give them back all the stuff except the password. If their password's right, I'm going to give them back everything from the player's table that matches their record. Fair enough? Okay, this is the syntax. I'll give you a copy of this. Okay, the top of it's the same. But instead of just saying returns table, this one up here I just said, and it took me, I had to read for 30 minutes this afternoon to figure out how the heck you do this. Returns a table. Okay, I have to give the table a name. And it's weird because I don't say return foo. I give the table a name. Here, returns that identifier. That identifier is a table, and the table has to match what I'm selecting. Okay, as begin. Okay, I declare a varchar 16. I call that real password. I go into the RPS players and I select the real password, gets the password that's in the table, where the player IDs match, the one that came to me in a parameter versus the one that's in the table. So now I've got the player's real password. And now I can say, if they match, okay, here's where it gets returned, and there's always something weird about the way it gets returned. It's weird in Oracle too. Insert into, foo, what's foo? Foo is the name of this table that I'm returning. Insert into that table, select PID, PDate, PName from RPS players where the PID equals the one that I received. The PID in the table equals the one that I received that I have now validated. with the password. I think that's a strange syntax, but that's the way it's done in SQL Server. If you need to do it in Oracle, you'll have to figure out how to do it in Oracle. They also have a strange syntax. It's not as simple as just return a select statement. Particularly, it is if you just have one row. Where I got into this mess here was when I wanted to have this statement and then this statement and then an if and then something else. If I can do it in one statement, and I could have, it's a lot simpler and it's a lot more intuitive. So I would just say return select everything from RPS players where I would have PID and PWD, where PID equals at PID and PWD equals at PWD.
The reason you don't want to return everything in the event that somebody just accidentally discovered the right password and you don't want to send it back to them.
Right. This one doesn't have this one doesn't take a password, but it's there. Yeah. Yes, it is. Yeah, I agree with you. This allows me though to return specialized data to the user without giving the user access to the tables. I could create a view and I could give the public user access to the view, and that would be fairly secure. So, but I can't, all the public users are all going to get the same view. I don't have any way to say, okay, who are you? And so this is like giving them a view that I modify and build specially for that particular user. I also have a way to get the user ID, but I wouldn't know who the user ID is if he came in from a web server. So all you can do is just, you have to send me your user ID and your password as two of the parameters to the function. And then I'll give you back the function. And so I can give you back 1 row or 50 rows. I think my test case here, let's see. So here's this one where I select from test table function 1 killer whose password is fee. If I execute that, I get back, I don't get back nothing. Okay, why not? Let's go look at that. There's nothing there. Execute. Now let's try it. Here. Now let's see it. Execute, and I see killer's real name is Bob and the creation date and all that. And I got that by validating his password. If I gave it a bad password and I say select the same thing, but this is a password that does not match what I have in there, I don't see anything. Now I could have accomplished that without as much trouble as I took on it. I could have accomplished it up here. Would have been a lot easier. Let's see, we make all this test table 2. And it is our break time. So I might modify this during break. So let's take a break, and then when we come back, I'm going to go over some Visual Studio stuff, and we are going to have to learn Visual Studio. I have discovered that Microsoft Access is not going to work.
What part of it isn't gonna work?
The part where we try to call the functions. We can see the tables just fine from within Access, but our Access forms do not have the ability to call a function in SQL Server. They have their own fairly rich functional programming. I mean, they're all Visual Basic, but they don't use functions from the database. Okay, I'm going to pause the recording. Okay, I have a reboot required for the Visual Studio, so I'm going to have to end the recording here, and I'll have to start a new recording when I come back from the boot. So end the meeting. Goodbye.